Hi everyone, welcome to this channel. Okay, in today's video we learn about greatest lower bound and least upper bound. So if you enjoy the video, like to this video and subscribe to this channel. Okay, so before going to least upper bound and greatest lower bound, we first know about maximum, minimum, maximal element and minimal element. So suppose this is a pole set. Okay, this is a partially ordered set. And A is the maximal element. A is the maximum. Okay, A is the maximum. If every element of this set B is less than A, then we say A is the maximum. Similarly, and A is said to be minimum if every element is greater than A. So, for example, in the power set of A, B, C of element A, B, and C with subset of equal to relation, it is obvious that phi is the minimum element because every element, phi is the subset of every set. Okay, so it is obvious that phi is the minimal element, and the set ABC is the maximal because every element of this set is subset of this set. So it is obvious that this is the maximum and this phi is the minimum. But if you consider this set, okay, this partial order set with the relation subset equal to, it has neither maximum nor minimum, because you can see here that if I take these two elements A and B, I cannot compare these two with the relation subset or equal to, okay, or B or C. Okay, so since this we cannot compare these two elements, so I cannot say which one is maximum or which one is minimum. So this kind of set doesn't contain maximum or minimum element. Okay, now we define maximal or minimal. So an element A of the power set partial order set A is maximal if for any B belongs to A and if B is greater than A. Okay, A is said to be maximal. A is said to be maximal, and if and only if suppose any B belongs to A which is greater than A, then B must equals to A. And A is said to be minimal if suppose any B which is less than equal to A. If there exists any B which is less than equal to B, then that B must equals to A. Okay, so this is the condition of maximal or minimal. Now we define the greatest lower bound and least upper bound. Suppose A with this partial order is a partial order set, and element G is called the greatest lower bound, or in short GLB of elements A and AB belongs to A if and only if G is less than equal to A and G is also less than equal to B. Okay, that implies if suppose you consider the number line, okay, set of integer, and I have elements 2 and 3. I have number which are less than 2 are 1, 0, minus 1 and so on. These all are less than equal to 2 or less than equal to 3. But here you clearly see that 1 is the greatest among all the lesser element. So this 1 is the greatest lower bound of 2 and 3 in the set of integer. Similarly, suppose if C is another lesser element, which is less than both A and B, then C must be less than G. That for us, if we understand with this example, so suppose that is suppose 0 is also less than 2 or less than 3, that implies 0 must be less than equal to 1, which is obvious. Okay, so this is the greatest lower bound. Similarly, least upper bound. Here in this above example, for 2 and 3 in the set of integer, we know that 4, 5, 6, etc. all are greater than these two elements. So the least among these greatest element is 4. 4 is the least element among the greatest element. So we say this 4 is the least upper bound. Okay, that implies that we can define that as L is a least upper bound. I would add as least upper bound of A and B if L is greater than both A and B, but if there exists an element C which are greater than A and B, that means that is also greater than the least upper bound. Suppose here if 5 is also greater than 2 and 3, that implies 5 also greater than equal to 4. So this is all about minimum element, maximum element, minimal, maximal, and the greatest upper bound and least upper bound. If anyone has any doubt or query, please comment. Okay, thank you.